Hi everyone, in this video I'm going to show you how you wire a transformer. So this will be the primary side and that will be the secondary side of the transformer, and this transformer is salvaged from a amplifier. So this cable will connect directly to the mains power supply, and you will also need a multimeter that can set it to ohms. So as you can see from the trace, current will flow through here down to there and across the jumper, across the fuse, and into the winding itself. This will be the primary winding of the transformer. So as you can see, that will be one end, and the other end as you can see, you can trace from here down to there across the jumpers and end up at there. So right now you are seeing no continuity because all these wires are just floating around. So depend on the mains power supply in your country, but for my case is 240 volts AC, so which means I will need to combine these wires to get the highest resistance reading on the meter. So let's measure one by one. That is 6.8, the another is 7.2. Then when I come to here, there isn't any continuity already. So we stop here, then start from here to there, up to here, and there you have it, 6.4 ohms. So we just remove all the wires. So link it back to here. And let's measure the resistance once again. So as you can see, is 13.4 ohms. So I will just take out this transistor tester. So let's slot the wires in and we can measure. So as you can see, it says 13.4 ohms and 17 henries. Then I will strip this cable off, and by the way, I have desoldered this away from the board. So one more thing, if your country has 120 volt AC main supply. Then you just have to parallel two sets of windings. So as you can see, I have stripped the wires out off camera because it's 240 volts. I will bridge this connection over here. And I have already hooked up the cable to this plug for testing. So the question is, will it go boom if I turn on the power supply in 3, 2, 1? Ah, that's good. No explosion or whatsoever. So now let's measure the voltage at the secondary side. And yes, there you have it, 240 volts across here and there. So now let's take a look at the diagram over here, which I have drawn out and reverse engineered. Then the peak voltage will be the VRMS, the root mean square voltage, times square root 2. So as you can see, if I get 14.4 volt AC here and there, I can actually add up to 28.8 volts. When rectified to DC, I can get up to 40 volts. And because this is a center tap transformer, I can get both positive and negative voltages out of it. So knowing the estimated DC output voltage is required because you need to know how to select a filter capacitor when you convert AC into DC. So this is what I have reverse engineered out. As you can see, there are two different bridge rectifier circuit because this board over here has built-in bridge rectifier circuit already for these two windings. So how this full bridge rectifier circuit works is that during the positive half of the cycle, current flow from here through the fuse, through the diode, and through these two capacitors in series, then out to here. However, during the negative half of the cycle, then current will flow from there through the diode, through these two capacitors, and out to here. So essentially you have actually two voltage output, one positive 20 volts, and you have a 0 volt or ground, then you have negative 20 volts. And there you have it. That is the positive, and I guess that one would be 0 and negative. Oops, just steady. And there you go, negative voltage, positive voltage. So of course this voltage value, this DC voltage value would be slightly lower because you have to account for the voltage drop across the diode and some power losses along the way. So for the next one, current basically flows from here into there, charges this capacitor up and down to here during the positive half, and during the negative half of the cycle it just flows the opposite direction. It goes from here through the diode, charges up the capacitor through another diode and back to here. Simple as that. However, there's a third design where you have a center tap transformer, output at the secondary winding, then you will have your capacitor here, then there's only 2 diodes instead of 4 connected in this way. So if this is 12 volts, 0 volts, 12 volt, the rectified output voltage is around 12 volts times square root 2. So take, which is equals to around 16 volts. So AC voltage looks like this. When rectified, becomes like that. It becomes like that. Then when it's filtered by the capacitor, it will become more or less a straight line. But however, if the DC output is loaded with a load, then it will look something like this. So you will see that you will have a ripple voltage. It will go down, and that's the time when the filter capacitor gets charged up, then you will discharge again, and so on and so forth, like that. And this is depending on the amount of current that you are drawing from the output. That will also determine the voltage regulation. So I hope you enjoyed the video. If so, please give it a like and subscribe. Stay tuned, and thank you for watching. Goodbye.